Okay, so this is the second of the two videos on finding the turning points and deriving their nature. In the last video, I found the two turning points were at -2, 13 and a third, and 6 and -72. I've got my original function of fx, but actually now I'm not going to be using that because I'm going to be focusing on my derived function now. Because remember, when we looked at the video for the turning points, if it was a maximum or a minimum does that. So therefore the gradient is positive 0 and then negative. A minimum does that. So the gradient's negative 0 and then positive. And then we had these 2 points of inflection where it's positive and 0, or negative and 0. Okay? So what I encourage you to do is think about putting a table in. You don't have to, okay? I'm not saying this is the only way of doing this. I know there are other ways of doing this. But if I choose my x values, and then I choose my f of x values, then I can look at my points. Now I'm doing a table of 5 points because the point in between these two, because there is no other turning point in there, can work for both turning points. So I'm going to choose the number 1 there. But the rest of the time I'm choosing numbers either side. And of course you just got to remember that a number smaller than -2 is -3. Even you guys should cope with that. So here's my derived function, x squared minus 4x minus 12. If I put these numbers into here, it will give me the gradient. Now I can work out the numerical gradient, but actually I may just want to work out if it's positive or negative, because that's the bit that matters. So let's actually get that going. Now again, exact same as we did last time, I'm going to use the table function in my graphics calculator because it just makes sense. I will show you how to do one manually. So my table function, I'm going to substitute -3 into my gradient function. So f dash of -3 is -3 squared minus 4 lots of -3 minus 12, so that is 9 plus 12 minus 12, which gives me an answer of 9. So that's the value that goes in there. Right, the rest of the values I'm going to do really quickly because I'm using the table function. Because 2 is my turning point, its gradient is 0. If I substitute 1 in that table, I get -15. If I substitute 6 in that table, I get a gradient of 0 because it's a turning point. And the last one I'm going to substitute in is 7, and that too gives me a gradient of 9, which is positive. So therefore I go positive, 0, negative, so that's a max. And I go negative, 0, positive, so that's a min. So therefore this one is a maximum and this one is a minimum. There you go. Calculus at work. Hope that made sense. If not, come and ask.